gentlemen, and thanks for being here. And I'm really honored to moderate the next session of panelists who are very experienced. Maybe let me start with a brief introduction on the topic. This is about pioneering energy efficient solutions for sustainable desalination. I'm sure all of you being the experts in this industry, you know the efforts that is done across the globe and especially in this region to provide energy efficient solutions for desalination. We would like to understand it a bit more from the esteemed panelists whom I would like to introduce for this particular session. I would like to invite Engineer Isa Alvar, Project Manager, Aqaba Aman Water Desalination and Conveyance Project, Ministry of Water and Irrigation, Jordan. Mr. Isa? Yeah, hi. Okay. A small introduction of Mr. Isa. He's a project manager and a deputy PMU director with over 10 years of experience in mega projects delivery in Jordan. He holds a master's degree in environmental engineering and infrastructure. Thanks for being here with us.
Thank you. Pleasure is mine.
Yeah. I would also like to invite Dr. Ahmed Hadi Mohammed. He's come all the way from Egypt, and he's the General Administration for Quality and Environmental Affairs Holding Company for Water and Wastewater, Egypt. Thank you. Mr. Ahmed has almost 19 years of experience in water treatment plants and labs through continue operating treatment, monitoring, analysis, etc. And he's also the focal point in Egypt regarding WHO in SDG 6 and GLAS program. Thank you, Mr. Ahmed, for being here. I would like to introduce Mr. Nazar Mustafa, Head of Operations and Maintenance for Water at Etihad V. Mr. Nazar has a very wide experience of almost 26 years in this industry, focusing in water production, distribution, transmission, and connection networks. Notably, he managed the RO plant at Kidfa for more than 7 years, and currently he oversees the operation and maintenance of 6 RO plants, including Galila and Al Zawra for Etihad V. Thank you for being here. It's our honor. And last but not the least, I would like to introduce Mr. Ismail Aloy. He's a principal at Rolandsberger Global Water Team. Mr. Ismail brings almost over 15 years of experience in the water industry. His background combines hands-on experience across water value chain from EPC and O&M companies with strategic insight developed at Rolandberger. Thank you everyone for being here with us. Thank you. Let me shift. I'm happy to be standing here. It's fine. Thank you. Thank you here. Thanks for being here. I'd like to start with a few questions. Maybe I would also like it to be a more interactive session, wherein if the audience want to add some more, I hope you're open to answer those questions also. Yeah. Starting with energy optimization in large-scale desalination plants. How can we revolutionize desalination to reduce its electricity energy footprint drastically in a truly sustainable manner? Maybe I would like to start this question with Mr. Nazar.
Thank you for giving me this opportunity. I think as mentioned in the previous session here, As the RO technology has advanced and the energy consumption of ROs now reduced by 60%. And at Etihad, our aim is to have a more efficient energy system throughout the entire process, from production all the way to the consumer end meter. And in desalination, as mentioned before, we have phased out all the MED plants, and also in the process of phasing out the old energy consumption, high consumption plants, replacing it with a new technology. Our flagship Naqa is one of the highest efficient model in the world. We're also investing in more renewable energy-driven technology for our future projects.
Yep.
Okay.
Maybe this is more from a production perspective or a generation perspective. I would also like to put the same question to Mr. Ismail from a perspective of a consultant, or from the perspective of an overall view.
Sure. Look, I think that reducing the footprint of, energy footprint of desalination plants requires a bit more than, just efficiency improvements. I think it requires, to rethink the way we approach, the production of desalinated water. As it was mentioned earlier, the industry has made massive improvements, with thanks to highly efficient now reverse osmosis membranes, but also advanced energy recovery systems. But I believe that now we are approaching the limits of the thermodynamics of reverse osmosis. So I think we need, if we really want to have a breakthrough, we should address it from a hybrid approach. I would say, number one, we should think of alternative technologies to reverse osmosis, or technology which could complement the reverse osmosis. And why I'm saying that is, we have, I believe, extensively optimized the RO. So now we are reaching diminishing returns. So we should think of technologies that plays or works with physics and not against physics. So we could think of, I believe my colleagues are more legitimate than me to speak about those technologies, but we could think of forward osmosis, membrane distillation, biomimetic membranes, etc., etc. Number two, I think we've been hearing a lot of industries embracing AI, and I believe that the desalination industry is a bit lagging behind. So I think we should consider how AI can optimize the operations of desalination plants and therefore reduce the energy consumption, because I really believe that even the best technologies is inefficient if it's not optimized almost in real time. And I think this is where AI can play a big role. It can predict and adjust operation parameters, and so, for example, to better meet the demand. So I believe this is, another room for energy efficiency. And third, I don't want to be too long. I think we should see how AI can help better meet the water demand. We are now, producing in a desalination. We're trying just to meet the water demand. I think we should think of how we can integrate, the desalination system into a smart type of water network, where the production is somehow continuously meeting the actual water demand.
Thanks. Maybe I think it's a race to the bottom from the production side, how to optimize it, to the technology development side. Maybe is there anything that you would like to add from a strategic point of view to this topic?
Sure. Thank you, Karek. As these esteemed colleagues mentioned it all, I'd just like to compliment a couple of important things. Now, we have to realize, and we're thankful that desalination technology is today is way much better than 20 or 30 years ago in terms of energy consumption. Maybe from a strategic point of view, there is a limit, there is a threshold, we cannot pass that. We need to desalinate the water for all these processes. So maybe enhancing the energy supplies in terms of CO2 footprint that can subsidize, or not, sorry, it's still early in the morning, I had a rough night. No, it can constitute, or this energy mix, if you introducing more renewables in a way that's efficient and feasible, then I think we have a smaller footprint at the end. The other thing I've been noticing lately in the tender we're going through, the financiers and these green funds, they very push to decrease CO footprint of the energy in desalination. They hate it, it's highly consuming, but I think the way to work on is around having less footprint at the end. Thank you.
Thank you. Thanks. It brings on to another question on the same topic. Dr. Ahmed, do you think it's possible to fully use renewable sources for a desalination plant 24/7 and completely change the way the power consumption is being utilized? I understand that for some projects in Saudi now, be it Red Sea or NEOM, this push has happened already. But what would be your idea or opinion? Do you think we can fully renewablize desalination plants?
Assalamu alaikum. Renewable energy, renewable source. In desalination, we can use the wind energy, solar energy, but solar energy present in night, not present in night, and the battery more expensive. That have difficult maintenance, and we can use the hybrid system between wind energy and solar energy. That's a hybrid system will be used in desalination in Egypt now, but in small scales. In small scales, in some place, coastal government in Egypt, but still more expensive, difficult in maintenance, in used, and do not have a background about it, large background about wind energy and solar energy in used in desalination planet. That may have more research and more applicable in the place in desalination planet.
Thank you. Engineer Riza, can it be a cost-effective solution when it comes to,
or to be dependent,
full renewable for desalination?
100% dependent on renewable?
Yeah.
I haven't seen it. We explored a lot this option.
Yeah.
We even thought of having CSP with solar, with wind, with hydro pump storage. If you want to pay $10 per meter cube, maybe it's doable. But when it comes to feasibility, I think we're very immature of reaching this, being dependent on renewables. They definitely decrease the cost.
Yeah.
It depends, each country has their own limitations of how much you can introduce renewables. But we see it as a way to decrease the cost, but be dependent on it. It's a dream for everybody, of course, to have a steady supply 24/7, but I haven't seen it yet from my experience.
Especially every country has its own advantages and challenges. Maybe Jordan or Egypt has the potential of wind, whereas UAE or Saudi may have the potential of solar. I think it also complements each other, and it is important strategically to plan it in such a way that we can get a cost-effective solution for
maybe in the future, but I strongly believe you need a strong base for 24/7. You cannot, your system will be very weak to deal with variations in the supply. Now there are solutions. I'm sure Corrado has much more than this, but from what we saw on a feasible, or let's say on a commercial scale, for a huge desalination. We wish to see this in the near future.
Doctor, you would like to add something here?
Corrado, I threw this on you, but I know.
There is a lot of sure development that have been deployed in the industry in this respect, and whereas I think I always believe that the industry can do whatever it is requested to them. It's simply to put the right incentives to do that. There are no technological barriers as such. The only barrier are, as Suleiman said before, is only to make the business to give the right business model.
I think if I have to compare it differently, 30 years back, if someone would have come and told us, why don't you change the technology to smartphones, we would have said, what are you talking? Where is this concept called smartphone? Even 30 years back, this region focused on power and water together, and it was always thermal desalination. But we moved from there to RO, and now we are talking about renewables. We have already done renewables plus RO. I think the evolution is going to be further better and better. It's just a question of time and where it takes us. Yeah. Maybe, Ismail, more to you on smart strategies for planning desalination project. Can you give us some insights on what do you think our smart strategies should be for planning an economically viable desalination project in the future? Yeah.
Yeah. First, I think we should, or I would like to challenge a bit a fundamental assumption that we take for granted. I believe that desalination should be, our last resort first. I think we should, it's costly, even if there were some huge savings made recently. The energy consumption is dropping, but still, it is an expensive technology. So I think that first we should have this desalination last policy. So we should maximize, all existing efficiency measures. I call them measures, but it's a bit more than that. Mm-hmm. So we should, there is no point, I believe, building a new desalination plant if the output will be lost in the network, like 15 or 20% of non-river water. So I think we should first tackle the reduction of NRW. We should also maximize reuse, or at least advance, the wastewater treatment to reach a good level of reuse. And we should not forget as well the other side of the equation. So we focus a lot on the supply. We should also talk and think of how we can also better manage the demand as well.
Yep.
So that will be, I would say, the first way I would look at it. And second, I think we should also challenge a bit we design desalination plants. Historically, I believe we were sizing desalination plant based on the peak demand, I want to say. And this sometimes, leads to overcapacity and underutilized assets over time. So why not think of desalination plants which are, let's say, modular. So we could think of a way to, increase incrementally the desalination plants in a way to better meet basically the evolving demand patterns.
Thank you. No. Sorry, please. Yeah.
I'd like to add just the idea is not only to produce water, we have to produce it responsibly. And we have to ensure that the entire system from production all the way to the consumer, every drop is saved. We have utilized the AI-driven smart ball leak detection through our network, where we have reduced NRW drastically, saving a lot of money and energy and of quantity of water. Also, one of our leading worldwide, one of the top leading water distribution center, Al Kharija, we have strategically located it at a high elevation to utilize the gravity flow. This led to a saving of more than 36 million kilowatt hour every year.
Oh.
So this is a tremendous saving of energy and impacting the carbon footprint. So the entire system has to be designed in an efficient and has to be in a way that it's energy efficient, and it's a continuous effort to optimize the system.
Agreed. Thanks. This also leads to my next question to Dr. Ahmed. Part of the story is to solve the water scarcity. We have desalination plants, we have plants that generate water, but at the same time, we should ensure that we don't create any environmental crisis due to that. As we have seen, because of certain brine discharge or certain changes, climatic changes, the seawater temperature changes, TDS changes, TSS changes, there is a bit of an impact, or there is an impact on the environmental conditions. How can we mitigate or reduce these impacts? How will we be able to ensure that we not only generate, we also protect?
Okay. As a first, we must apply the environment impact assessment plan.
Yes.
That must be created under desalination water safety plan, under any name, but environment impact assessment must be applied under the handoff laboratory system. All the control, quality of water, the brine from brine discharge, and we must face about the desalination plant must be construct another planet to brine industry as industrial, or remove, but not effect on the environment marine. We can use dilution, we can use the industrial system, but we must construct another plant behind the desalination plant. That's one. Another point, laboratory system must be work with parallel as engineering system. The chemist work with engineer. In our country, engineer number one, chemist, that's two stage. That's not correct. Chemist and engineer work with us.
Together.
That's my vision about that's environment and the climate change. In desalination, we must focus about environment impact assessment plan and the desalination safety plan. Desalination safety plan. That's a plan take about from intake, catch, intake, from sea to sea, from catch to the cap.
Yep.
That's a plan cover all of this, from catch, that's intake of desalination plan, to the sea, the cap, That's consumer, building, environmental impact assessment. All of these processes under this plan. We must apply this desalination safety plan. Will cover all of this. Will cover environmental impact assessment. Will cover control the quality, control the protection, control distribution, water net, all of this from sea to the sea. And we must not neglect the sewage. Sewage from T to T, from toilet to table will be included in
the.
Thank you.
Thank you. Issa or Ismail, you would like to add something to this, especially on any new technology development in terms of?
Yeah, there are many. First, I think after we distinguish where this environmental threat is, whether it's in the marine works, whether it's in the discharge, whether it's in the construction itself, I think there are many processes or let's say technologies that deal with this properly. You can very limit the negative effect to the environment. Now we're talking CO2s. Before we were talking brine, for example. These high-speed diffusers came into place. I think they resolved one of the biggest issues of desalination by having this plume created. So I think as if we keep, and every developer and every major EPC will have this red line to have the minimal damage to the environment, because later on everybody will be held accountable for it. And I think in general we're talking about a safe, clean technology as desalination, but so as any other construction or any other thing you'll be doing, it will have a negative impact and we need to mitigate it.
Thank you. Thanks a lot. Nazar, what do you think about machine learning and AI in desalination? Do you think they can work together on optimizing desalination solutions? Please, it's also another open question to other panelists. I would start with Nazar.
I think AI is a new technology and it's rapidly growing, and integrating AI into desalination will lead to a tremendous saving in an operational cost if we integrate AI into the live monitoring and control of the plant throughout the machine learning. And also, we have utilized AI throughout the smart ball technology. We saved a lot of leaks and a lot of non-revenue water. We have started implementing AI in our preventative maintenance. This led to a very efficient maintenance program and also inventory control that saved a lot of things. I think AI is developing and technology is developing. We will see more AI in the future in the desalination and an entire water management. That's what I think.
Yeah, maybe if I have to add here, it's not just one solution that fits all. What we have seen is also that when it comes to even development phase, when it comes to even initial stages of a project, people are looking at digital twins or using AI for modularizing the engineering solutions. And the operations phase, they are looking at digital twins. And then again on transmission and distribution of water, smart meters, data collection and machine learning and gathering, and also educating the customers how they can save water, thereby save their water and electricity costs. AI is quite helpful even on these aspects. I think it's moving towards a trend where it's more and more getting integrated into our regular lives and systems. Sorry, anything you would like to add?
Yeah, I wanted to add a point on the environmental impact. of desalination. I think we have the tendency, to focus on the, I'd say, the carbon impact through the energy consumption and also the impact of brine most of the time. And there is one topic which is, for me, quite often overlooked, which is, the disposal of the reverse osmosis membrane. We use, a lot of modules, a lot of membrane elements. We replace them every year, etc., etc. And today, they end up in a landfill. So we should not forget to think about, solutions to help also address this. And usually those chemicals are let's say, polluted with chemicals. They have chemicals in it. So this could create, leachates in those landfills. So we should not, forget this from the sustainability equation. So ideally, we should think of how we can extend further the life of the membranes. We should also think of, how we can repurpose those membranes. So I know there are some startups thinking of how we can use those membranes for, why not, brackish water or even reuse. So there is this. Another element could be, how to maybe drive innovation and, create technology which could help us, recycle those membranes, and why not, get back those elements that, constitute the membrane. So imagine you can recover those polymers. So, of course, I will not talk about biodegradable membranes. I think this is something which is out of reach. But we should clearly not forget the impact of those membranes and the impact on their environment. And so I think the solution is not easy, because it will include and involve as well, joint effort from OEMs, the membranes manufacturers, but also the operators and the researchers and scientists.
Thank you.
About AI in desalination, now we applied the mobile application that will collect all data, quality data, and laboratory data, and that's all data by remote sensing and some sensors in the intake. But we facing about the cloud must be more safe, not hacking.
Yeah.
The hacking on data, that's more difficult. We must save this data. We in Egypt, in holding company, now the quality of environment affairs, we build program and mobile application. We make it to save our data.
Correct.
That's the most saving data from hacking on it.
Agreed. Cybersecurity is quite key here.
Cybersecure.
Anything? I'm surprised the topic was pioneering energy efficient solutions for sustainable desalination, but I think we moved from energy efficiency to digital learning or machine learning or artificial intelligence, to how we save the environment. I think there was quite an insight in the feedback that we got from the panelists, and I would say it's a bit wide-ranged in terms of not just energy efficiency, but also in terms of how to do it, what are the benefits to it, what can be done differently, where is the technology taking us now, how do we save the environment in terms of ensuring that be energy efficient and also be careful in terms of nature, etc. Thank you. Thanks for such insights. I would give a big round of applause to the esteemed panelists here.